Next question number 23. Limit x tends to 0, square root of 1 plus 3x square minus cos 2x over x square. X approach to 0. So what happened? You put x for 0, here 1. Square root 1 is 1. Here x for 0, cos naught is 1. 1 minus 1, 0. Below also 0. So more any other method. This is straight substitute gives you indeterminate form. So we follow any other method, right? Factorization, the trigonometric part also available. Usually trigonometry here for what? Sin theta over theta or tan theta over this the pattern. Cos no matter because cos naught is 1. Okay, now we rearrange, see the method. Limit. So therefore we try to convert the cos into sine. Take the cos into sine. Then there's a possible chance for answer, the unique solution, that means perfect limit exist value. Therefore see square root of 1 plus 3x square, and I additionally write two numbers. I add the 1, subtract the 1. See that minus 1 plus 1, that is 0. Minus 1 plus 1, 0. Otherwise write cos 2x what? Cos 2, what is cos 2 theta? 1 minus 2 sine square theta. That's I am rearranging here, right? And minus cos 2x over below x square. Okay, numerator is x square. Now I write in two parts. Two parts this limit problem. Limit x tends to 0, square root of 1 plus 3x square minus 1 over x square. This is one part of the problem, right? The other one is 1 minus cos 2x over x square. Okay, right? So hereafter, limit x tends to 0, square root 1 plus 3x square minus 1 over x square. Now I change this one, sine double angle formula. What is cos 2 theta? What is cos 2 theta? 1 minus 2 sine square theta. Therefore 1 minus cos 2 is what? 1 minus cos 2, 2 sine square 1 theta. Therefore this is 2 sine square x over x square. The straight theory here, sine 2 theta over that pattern, sine theta over theta form, that is. So I add the minus 1 and subtract the minus 1. Otherwise you can show cos 2x is what? Cos 2x is what? 1 minus 2 sine square x form, right? But here what is, actually here there are two questions. The problem, now divide into two problems. One is this, the other one is that. Here if you see, put x for 0, once again 0 over 0, meaningless. Therefore the idea of this type of question, what we done in earlier videos also, is my third video. But the conjugates method, multiple up and down by the numerator, denominator by the numerator's conjugate. So if I show here, limit x tends to 0, 1 plus 3x square square root minus 1 over x square, multiple by what? Conjugates mean what? 1 plus 3x square plus 1 over square root 1 plus 3x square plus 1. Okay, this is one part. And here the other one is what? Plus. There's a 2. Sin x over x, all things square, right? Sin x over x all things square. Sin x over x all things square. So wherever I use this conjugate form, it becomes a factorization pattern, a minus b, a plus b form, right? Therefore limit x approach to 0. See numerator, square root 1 plus 3x square minus 1, square root 1 plus 3x square plus 1, like a minus b, a plus b, that is a square minus b square. A square, therefore square root vanishes, that's why we are using the conjugate multiplications. Minus 1, okay, below x square into square root of 1 plus 3x square plus 1, okay, and plus what is that? 2 into 1, if you apply the rule, sin theta over theta, sin x over x is 1. Here see what happened, 1 1 cancel, see 1 minus 1 cancel, 3x square remaining, below also x square cancel, therefore 3. Put x4 note, put x4 note, 1 1 2, check that, plus 2, is it the answer? 3 and half, that is 3 over 2, 4, that simplify, the value is 7 over 2, right? 7 over 2, or 3.5 or 3 and half, right? Is that question? Next problem 24. Problem 24. Limit x tends to pi by 4. X tends to pi by 4. 1 minus tan cube x. 1 minus tan cube x over cos 2x. And the important question. So my target, we can make more than 50 problems. I can show this video series. Vectors I complete only 30 questions full essay type applied maths vector part. This pure maths. Limit one of the exam question, 25 marks, the structured paper. If you practice this simply becomes easier problem. So put x4 pi by 4, you know tan pi by 4 is 1. So 1 minus 1, 0. Here what is cos 2 times pi by 4 is pi by 2. Cos 90 is 0. 0 over 0, one of the meaningless form. Therefore, use any other theorems or factorization ideas or anything. I try, you know that you can convert to cos 2 also, tan double angle formula. What is cos 2 theta? What is cos 2 theta? 1 minus tan square theta over 1 plus tan square theta. Therefore, there is chance for tan this problem. Also, if I factorize 1 minus a cube minus b cube pattern, a cube minus b, refer that factorization. What is a cube minus b cube? A minus b, a square plus ab plus b square. So can I show that limit x tends to pi by 4, factorize 1 minus tan x, a minus b, other one what? A square is minus a plus, multiple the both, and tan square x. Okay, and what is cos 2 theta? 1 minus tan square x over 1 plus tan square, is it? Cos 2 theta in terms of tan. Also we have sin 2 theta, what is that? 2 tan theta over 1 plus tan square theta, that is sin. Okay, here see 1 minus tan square is again factorize 1 minus tan 1 plus tan, 1 minus tan 1 plus tan, here 1 minus tan cancel, 1 minus tan is cancel, right? Therefore limit x approach to pi by 4, this 1 plus tan goes up, right? 1 plus tan square into 1 plus tan x plus tan square x over what? What happens, you can cut one thing here, 1 minus tan, 1 minus tan cancel, 1 plus tan is balance. Okay, 1 plus tan is balance. So that's all. Now apply the value all at tan. Tan 45 is 1, tan pi by 4 is 1, 1 plus 1, 2. Next what? 1 plus 1, 3. Below 1 plus 1 is 2, therefore the answer is 3. With properly approach only, you can take the such a neat, clear answer, right? That's the answer of question 24. Next question 25. Problem 25. 1 minus sine 2x. 1 minus sine 2x minus cos 2x over 1 plus sine 2x, 1 plus sine 2x minus cos 2x. Find the limit value of this when x approach to 0. Stop the video, try your own. That's the method. Don't copy this. Try. There's a various method for particular problem, but the answer finally is same. You also try. Sometimes you was easy than me. Check that. X approach to 0. So what the idea? We have standard theory for sine theta over theta and tan theta over theta. So in this problem, sine 2x available, sine 2x available, that can be converted to sine 2x cos 2x, sine 2 theta, 2 sine theta cos theta form. Also cos 2x convert to sine form. Therefore, limit x approach to 0, if I rearrange like this, 1 minus cos 2x, separate it, minus sine 2x, same below, 1 minus cos 2x, next what, plus sine 2x. Now convert to trigonometric part ideas. What is 1 minus cos 2 theta, 2 sine square 1 theta, that is limit x approach to 0. So what is that? 2 sine square x. Okay, what is sine 2x? 2 sine x cos x minus 2 sine x cos x over the same 1 minus cos 2x, 2 sine square x, sine 2x what? 2 sine x cos x. What is next? Now apply these, take sine x out, take the 2 sine x out, take the limit x approach to 0, take the 2 sine x common factor out, 2 sine x out, what is that? Sine x minus cos x over, take the 2 sine x out here, 2 sine x, that is again what? Sine x plus cos x is it. This cancel. Now we write the x for 0. The problem is 0 over 0 meaningless, or infinity over infinity meaningless, no matter any other thing. So put x for 0, sine naught naught cos naught 1, sine naught naught cos naught, so answer is minus 1. Limit x is, the answer is minus 1, right? That's the problem. So very important question, full revision type. We did many problems in the theory class. So revision class, some additional problem I am showing here. Next question number 26. 2 over sine 2x. 2 over sine 2x minus cot x. Here say limit x tends to 0. Always you spend few seconds to milliseconds to straight substitute and check what happen if you straightly substitute x for 0. Sine naught naught 2 divided by naught, infinity. You know, tan naught is naught, so cot naught is 1 over naught, no, reciprocal cot theta, 1 over naught, infinity. Check, I think my second meaningless pattern, infinity or third one, there are 7 meaningless patterns, 0 over 0, infinity over infinity. Also we have, you can say 0, infinity minus infinity, not 0. That is one of the meaningless pattern, right? You can't determine this. That's happened here. Direct substitute is that you can't work it. Therefore, use any other trigonometric issues. Use double angle method, any method, cot theta, tan theta, cos over sine, or using any form. Limit x approach to 0, sine 2x. What is sine 2x? 2 sine x cos x. Okay. 2 sine x cos x. What is tan theta? Sine divided by cos is tan theta. So what is cot theta? Reciprocal, cos divided by sine. So that is cos x divided by sine x. This 2 cancel. And I use the LCM method to simplify, get the single fraction. Limit x approach to 0. And here the sin x cos x, sin x cos x, sin x cos x, the LCM part, then becomes here what, this is 1 minus here what, cos square. Okay, so use any method here, limit x tends to 0, 1 minus cos square sin square, 1 minus cos square sin square over sin x cos x. 1 sin cut here below, 1 sin cancel. So limit x tends to 0, sin x divided by cos x tan x. Now write x for 0. Tan not, answer can be not. Any problem, answer can be not, answer can be infinity, but it won't come one of that 7 meaningless form, 0 over 0, infinity over infinity. Those you can't correct that pattern. Okay. Next question, 27. 27th problem. Limit x tends to 2, square root 2 plus another square root inside 2 plus x, right? Square root 2 plus, within square root 2 plus x minus 2 over x minus 2. This is an important question. Complete algebraic part, irrational pattern, square root form. So you know many problems in the past you work in the class this type. Remove the square root is the main issue. What happens if you put x for 2? 2 to 4. Square root 4 is 2. Again 2 plus 2 4. Square root 4 is 2. 2 minus 2 0. Below also 0, so you can't do that. Straight substitute. So you have to use any other mode. We take the conjugate. What is the numerator part? Its conjugate, multiple up and down. Limit x tends to 2, the big square root 2 plus 2 plus x minus 2 over x minus 2. You multiple above and below by the conjugate of the numerator. What is that? 2 plus square root 2 plus x, everything the bigger square root, minus 2 means plus 2 conjugate, plus 2 over 2 plus square root 2 plus x plus 2. Okay, is the method when you use such a problem. So wherever we use the conjugate's multiplication, it becomes a factorization form a square minus b square pattern. Here square root minus 2, the same square root plus 2. Therefore a minus b, a plus b, when you multiply square root vanishes. Show that one. Limit x tends to 2, this minus that, the same plus. Therefore this square minus 2 square. So the bigger square root only removed out, vanishes, eliminated, right? So that is 2 plus the other square root available and minus 2, minus 4. Okay, a minus b, a plus b, a square minus b square, right? Over x minus 2, and what the remaining part here, square root 2 plus square root 2 plus x, outside plus 2. Okay. See, further simplify what happened. That is now limit x tends to 2, x tends to 2, here square root 2 plus x, square root 2 plus x, 2 minus 4. What is 2 minus 4? Minus 2. 2 minus 4 minus 2. Okay. That's the final there in the numerator. Over x minus 2 square root 2 plus square root 2 plus x, and outside 2, right? Check that. Is it okay? Check value. Then what happened hereafter? What happened hereafter? If you apply once again, put x4 2, put x4 2, 2 plus 2 4, square root 4 is 2, 2 minus 2 0, below 2 minus 2, once again the meaningless form. Very long question, simple problem but too long. Again we use it, the conjugate of the numerator, okay? Then only vanishes, we can get the exact unique solution. So now once again multiple up and down by the conjugate of the numerator. What is that? I show here limit x tends to 2 plus x square root minus 2 multiple 2 plus x square root plus 2. Okay, above and below, right? Too long, erase it. Below what? Only we have the x minus 2 and square root 2 plus 2 plus x, and outside the 2, and additionally multiple but conjugate. It's conjugate 2 plus x plus 2, right? Plus 2, long work but simple. So what the limit x approach to 2, x tends to 2, see where I use the conjugate form, factorization, a minus b, a plus b, that is a square minus b square, okay, over x minus 2, and here what, square root 2 plus x plus 2 outside, and here the additional multiplication, new multiple part. Now see what happened. What the numerator, if we simplify what the numerator, is it x minus 2? 2 minus 4 is minus 2, x minus 2, here x minus 2, right? So that x minus 2 here, x minus 2 cancel. That both x minus 2 parts are cancelled. Now you can apply x4 2. Now check by put x4 2, what happened? 1 over, right? 1 over. Put x4 2, 2 plus 2 to 4. Square root 4 is 2. 2 plus 2 is to 4. Square root 4 is 2. And here also 2. Here the same method. 2 to 4. Or say 2 plus 2. So answer 1 over 16. So limit exists. Answer is 1 over 16. Right? That's the problem. Next question 28. In problem 28. Limit x approach to 1, x third root minus 1 over third root x minus 2 plus 1. See how that form. Find the answer by using any method. This is a third root of power 1 over 3. What happens if you put x for 1? Check that. Above 1 minus 1 0. Below minus 1 power 130, that is minus 1. Minus 1 plus 1 is 0. Both above and below, both of that are 0. Therefore one of the meaningless pattern. So think any other mode to simplify that. So you can use maybe the algebraic first rule of the algebraic rule, x to the power n minus a to the power n over x minus a. Is it possible? Check that. Check that. Limit x tends to 1. Okay. X to the power 1/3 minus 1 also same power 1/3. Okay, then right below without the power x minus 1. Okay, that's the rule, first algebraic rule of limit. See next one, there is 1 over, right, this also x minus 2 power 1/3. Here plus 1 should be how then? Minus 1, is it power 1/3? Then below what? Without the power, right? Without the power. Okay, x to the power n over a to the x to the power n minus a to the power n. Below without the n terms, x minus a. Check, is it okay now? This is available. This part also, see, minus plus, okay. And here x minus 1, here also it becomes x minus 1, no? Minus plus 1, so cancel. So no any additional terms here. Therefore we can apply the limit rule. X to the power n minus a to the power n over x minus a. X tends to a. That x tends to 1 becomes 0. So what the answer? N a to the power n minus 1. That is 1. That again multiple here, 1 over the same method, n a to the power n minus 1. So n a is minus 1 to the power that is minus 1. So the answer, what happened, that is 3 cancel. Answer is n a to the power minus 1. Check that. Is it okay? 1/3, 1 to the power is okay. 1/3 minus positive 1. Here 1 over n a to the power n minus 1 means what? 1/3 minus 1. That is minus 2/3. Is it minus 2/3? Minus 2/3. You see 1/3 cancel. It's very important. Sometimes silly mistakes. Therefore incomplete answer, incomplete solution yours. Be careful. Minus 1 to the power minus 2/3 is what? How that value? Minus 1 to the power minus 2/3. Okay. Can I write this one? Minus 1 and a square here and a minus 1/3. Check like this. some indices application. Power and power multiple is this square. Minus 1 square is positive. Minus 1 square is positive. So 1 to the power anything is, that is 1, right? Therefore here plus 1, check the answer, not minus 1. Answer is plus 1, check method that. Next question 29. Problem 29. Limit x tends to minus 1, third root of x, third root of x, third root of x plus x square plus x plus 1 over x plus 1. So best thing you try that. Go stop the video, you try. But no matter the problem, answer becomes error, wrong answer, correct answer, no matter. Try and see, keep it. Then only, if same problem comes once again somewhere in the paper, future exams, you can minimize your duration, time interval for that problem. So check how this. Directly substitute what happened. What happened? The direct substitute here, put x4 minus 1, minus 1 power 1/3, that is minus 1, right? Here plus 1, so 0, minus 1 plus 1, 0, below also 0. Therefore no answer to get such a way, right? Therefore we rearrange something, use simplification or factorization form. How that? Can I divide into some parts? Limit x tends to minus 1. Can I write this one? X to the power 1/3 and plus 1 there over x plus 1. Is it okay? Part of the expression. Not only that. Plus, here what happened? X square plus x over x plus 1. Now we can use the algebraic limit. X to the power n minus a to the power n, that pattern, check that. But there should be a minus, no? X to the power n minus a to the power n. Should be minus, minus. We have to rearrange to negative. So limit x approach to minus 1. What is this? X to the power 1/3 minus, can I say the minus 1 to the power 1/3? Minus 1 power a number or fraction, answer is -1. Then below what? Without the power. X minus minus 1. Okay. That's plus 1 actually. And here what happened? Take the x out, take the x out, then x plus 1 over x plus 1, right? Therefore, here you can use the limit rule, number 1 algebraic rule, this rule, 1/3 n a to the power, deduct 1 to the power, minus 2/3. So earlier question I showed that this positive, this is the plus number, as I shown in previous problem, that become a plus value, positive value, right? Okay, here what happened? X plus 1 cancel x. Okay, now simplify this. This is positive 1, right? Therefore 1/3. There put x4 minus 1. So the answer minus 2/3, right? Limit exists minus 2/3. If you directly substitute, there is a different answer. That is a meaningless pattern. Next question number 30. So you can work more than 50 questions. I expect to show there's no any other problem. If you continuously follow this my video series, I'll show all type future problems, past problem, expectation, everything. If your theory is clear, You identify what I am showing you, a method of simplification. The idea is what the concept of the each and every lessons. Next, limit x tends to pi by 6. X tends to pi by 6. 2 sine square x. 2 sine square x minus 3 sine x plus 1 over, below that, 4 sine square x minus 1. 4 sine square x minus 1. Simple question, but trigonometric part. See what happen if you directly here pi by 30 degrees, sine 30 half. So here 1/4, 2 and 1/4 is half. Here what, minus 3 over 2 plus 1, 0. Check the numerator is 0, denominator is 0. Therefore, see this both the quadratic expression, like a algebraic part. 2x square minus 3x plus 1. You can factorize. See, you can factorize the numerator also below what? Like a 4x square minus 1, 2x minus 1, 2x, primary class factorization. A square minus b square, a minus b, a plus b. So that is limit x tends to pi by 6. How to factorize? 2 sine square minus 3x, that other one 2 sine. That is what? 2 sine x minus 1. Okay, here. Then sine x plus 1. Is it? Check that, check that. 2 sine square plus 2. Here. Minus 1. Minus 2, minus 2. So that's the answer. Over is factorization, a square minus b square pattern. 2 sine x minus 1. Next 2 sine x plus 1. So what happened is both cancel. Now put the solution, put the 30 degrees, x for pi by 6. Sine pi by 6, half minus 1 over 2 into half plus 1. So 2 cancel. Here half minus 1 minus half. Therefore quarter, that one simplify, the answer is minus quarter, no, minus 1/4. Minus 1/4, that's my question 30. Next question 31. Problem 31. Cos cube x minus sine cube x, cos cube minus sine cube over 1 minus tan square x. Find this value when limit x tends to pi by 4. Limit x approach to pi by 4. And the good question to simplify trigonometric part. See how that you can factorize the above. Now a cube minus b cube pattern, a cube minus b cube pattern, factorize. So before that, try to straightly substitute pi by 4. You know, pi by 4, sine pi by 4, cos pi by 4, same answer, 1/√2. Therefore numerator is 0. Below, what is tan pi by 4? 1 minus 1, 0, meaningless pattern. Therefore use any other idea of simplification. I can factorize the numerator. Then there transfer a cos double angle. Check, we'll see. So a cube minus b cube. What is a cube minus b cube pattern? A minus b, a square plus ab plus b square. So limit x tends to pi by 4, factorizing cos x minus sin x. The other one, cos square x plus sin x cos x plus sin square x. Okay, that. Here now too, don't miss you, don't say a square plus 2ab plus b square. That is different. For the cubic factorization of that, that is a plus b all things square, binomial part. And here 1 minus. Can I write the tan square is what? Sine square over cos square. Sine square x over cos square x. Okay. So limit x tends to pi by 4. Okay. Cos x minus sine x, the one factor. What is that? Cos square plus sine square is 1. 1 plus sine x cos x. And here what happened? Cos square LCM, use the primary fraction LCM, simplify. 1 times cos square, everything below cos square, can I take up? Therefore, into cos square over cos square x minus sine square x. Okay. What is cos square minus sine square? Cos 2x. Actually, that is cos 2x. But don't put cos 2x. Say factorization. Cos x minus sine x. Cos x plus sine x. Therefore, cos x minus sine x cancel here, right? So, limit x approach to pi by 4. 1 plus sine x cos x into cos square x over, I cancel one thing, but the remaining cos x plus sine x. Cos x plus sine x. Now write the remaining values. Now put x for pi by 4. 1 plus sine pi by 4, 1 over root 2. Again 1 over root 2. Square of the pi by that half. Okay. And 1 over root 2 plus 1 over root 2. So simplify that part. To simplify, there's a value of this question. So here the answer become 3 root 2 over 8. 3 root 2. I hope you can try this. 3 root 2 over 8. That's the answer. So if you practice more problem, you can minimize the time. It's not a homework. It's a final exam paper question at that time. So if you work in the classroom or such these through this platform of YouTube or any Zoom or Google Classrooms, you have to work with the teacher, you have to work, you have to practice, it become easier. See next question 32. Problem 32. Limit x approach to 0, x square plus 1 minus 1 over square root x square plus 16 minus 4. See another problem using that. To direct substitute, see what happened. X for 0. Here 1, 1, 0. Here for square root 16 is 4. 4 minus 4, 0. So we use, but this question main part is conjugates. Using the conjugates, remove them. So in this case, both numerator, denominator, both are negative part of the expression. Therefore, you need the two conjugates, numerators conjugates and denominators conjugates, multiple both. So two long part therefore. So that is limit x approach to 0, square root x square plus 1 minus 1. Multiple its conjugate, x square plus 1 plus 1. That's the complete. Below also we need x square plus root 16 plus 4 over. So first I multiple up and down by the numerators conjugate. Okay. And here's x square plus square root 16 minus 4 its conjugate. X square plus 16 square root plus 4, right? Check that. Given problem 2 expression only 2, but later it become totally 4 newly added expressions 1, 2, 3, 4 using conjugates. So wherever you use the conjugate idea, it become factorization form. Take this 2, then only square root vanishes. A minus b, a plus b, a square minus b square. Okay, and remaining there x square plus 16 plus 4 over also square root x square plus 1 and outside 1. Here use the factorization. X square plus 16 minus 16, is it a square minus b square form? And now see here, plus 1 minus 1 cancel. Here x square remaining. See also plus 16 minus 16 cancel. Here x square remaining. So what happened? That is cancelled. Take that x square cancel. And now we put the answer. Put x for 0. Put x for 0, simplify. 0 square root 16 4. 4 plus 4 8. Here 1 1 2. The answer is 4. So limit exists. If you properly follow this way only, you can get the answer. Limit exists value is that. Okay. Next question number 33. Question 33. Limit x approach to 0, 1 plus x its third root minus 1 minus x its third root over x. I'll give a couple of questions. You try. Next video I'll complete the rest with this, showing these answers also. Next question number 34. Problem 34. Limit x tends to a square root x minus b minus square root a minus b over x square minus a square, where a greater than b, right? The given a greater than b. Try this also. And next one, question 35. Problem 35. Limit x approach to 0, 1 plus x square third root minus 1 over x square. And the question 36. Limit x approach to 1, x square minus root x over root x minus 1. So I hope you can do this in as a homework. Try. Next video I'll show it. Already my series model paper answer, I want to show one of my 5th structured type solution. So the other video I will publish that one. Also for the juniors, I am publishing that polynomial reminder theorem problems. That is that particular series of videos. Also with additionally limit series of videos. So everything, if you contact this YouTube channel continuously, you can get some high knowledge, additional knowledge than what you learn in the tuition class, in our class also. Some extra problem I'm showing here. So keep in touch, and newcomers subscribe this, then you will continuously follow my all types of this advanced level combined maths under the Bright Academy. This our what you call the YouTube channel, Candy.